Hi, my name is Jan Molak, and I'm the author of serenity-js, a next-generation, full-stack acceptance testing framework. What I'm about to show you today is how you can use serenity-js together with other libraries and frameworks you already know to design high-quality, layered, and reusable automated acceptance tests that are easy to write, cheap to maintain, and can scale to multiple projects and teams. Okay, so let's get down to business. As you can see, I'm using IntelliJ, but if you have another editor or IDE you prefer, they'll do just fine. What you're looking at right now is a standard Node.js project I've created using one of the serenity-js template repositories you'll find on GitHub. In my package.json file, I've added dependencies on several serenity.js framework modules that will allow me to write both web and REST API-based acceptance tests and produce test reports. Serenity.js framework consists of several Node.js modules, providing adapters to help you integrate the framework with other tools, test reporters, and most importantly, building blocks for you to create your tests with. You can learn more about the framework and its modules at serenity-js.org. I've also added a dependency on Jasmine, a popular test runner which I'll use to run the API-based tests, as well as a dependency on Protractor. I also have the Chrome driver module here, which will allow me to run my UI-based tests in a headless mode to avoid the browser popping up and interrupting our flow. As you probably already know, Protractor is a wrapper around WebDriver that was developed by the Angular team. Please note, however, that even though Protractor was developed by the Angular team, you can use it to test non-Angular web apps as well. In fact, I will show you how to use it to interact with a Vue.js implementation of the well-known To-Do MVC app, which I have in the app directory. The app itself is served using a popular Express web server. In my package.json file, you can also see a dependency on TypeScript and tsNode, which will allow me to run my TypeScript tests in memory without having to transpile them to JavaScript files first. Now, even though I'll be using TypeScript in this demo, serenity.js supports writing tests in both TypeScript and JavaScript, so you can use whichever language you're more comfortable with. Another thing I've added here is a couple of scripts to help me run and test the application. You can run those scripts via npm run, followed by the name of the script, for example npm run lint, or by telling your IDE to do it for you. So let's start the server and have a quick look at the app. As you can see, the app is running on port 8080 and has a title that indicates the framework it uses. Now, the scenario I would like to automate looks as follows. I would like my test to navigate to localhost port 8080, add an item to the list, and ensure that the list contains the item I added. Easy enough. But here's a question for you. How would you approach automating such scenario? What would be the first thing you'd implement? If your answer was page objects, well, I'll try to change your mind. Instead of using the traditional page objects model, let me show you an alternative my colleagues and I called the Screenplay Pattern, one of the key patterns behind serenity.js. The Screenplay Pattern uses a system metaphor of a stage performance, where each test scenario is like a little screenplay, describing how the actors should go about performing their activities while interacting with the system under test. Now, despite the word screen in its name, the Screenplay Pattern has nothing to do with the computer screen. In fact, it can help you break free from UI-only based testing, as it's a general method of modeling your acceptance tests that's not bound by the limitations of any particular interface. The Screenplay Pattern is actor-centric, which means that users or user personas, as well as external systems interacting with the system under test, are represented as actors. The very first thing we introduce in a serenity.js test is an actor. The names you give your actors are entirely up to you. The pattern I like to follow here is to name them after the personas they represent, which gives me a nice way to connect the acceptance tests with personas that the user experience teams come up with. Once we have an actor, we can ask them to attempt to perform a series of interactions with the system under test. For example, we can tell them to navigate to a website. Do you remember when I told you that serenity-js modules provide you with building blocks to design your tests with? Well, the interaction to navigate, like many other web-related interactions, comes from the serenity-js Protractor module. So let's run the test and see what happens. Turns out that telling an actor to do something for us is not enough. As you can see, Serenity advises me that in order to navigate to a website, an actor needs an ability to browse the web. Abilities are the second building block of the Screenplay Pattern. They enable actors to perform interactions by providing them with access to lower-level testing frameworks and integration tools. So let's teach our actor how to browse the web using a Protractor browser. And again, you can see that the ability to browse the web is distributed together with other Protractor and web testing related interactions as part of the serenity-js Protractor module. It connects the serenity-js test with the Protractor browser object. When I run my test again, Serenity reports that the actor has successfully navigated to the web app. Of course, we didn't see the browser popping up as I'm running the test in a headless mode. However, if you prefer to see the browser, you can change that in the Protractor configuration file. Interactions, like the one to navigate, are not the only things abilities enable though. The third element of the Screenplay pattern is questions. Questions provide actors with a way to retrieve information about the system under test. Again, serenity-js provides you with plenty of popular questions you can use in your tests, and you can easily create your own if you need. So, let's look at some questions that come out of the box. For example, we have a question to retrieve the website title. As you remember, it indicated the front-end framework behind the UI. So, what can you do with a question? You can tell the actor to answer the question and use the answer in another interaction. For example, an actor could log the answer to a question, which is very useful when debugging your tests. As you can see, when I run the test again, the test execution log now mentions the value of the website title. Okay, but obviously, this is not the only use case. More importantly though, you can use questions to perform assertions. Here, I'm using the serenity-js Assertions module to tell the actor to ensure that the system under test is in a correct state. In particular, I would like the actor to ensure that website title starts with Vue.js. Let's run the test to see if this requirement is met. Terrific. So far, so good. Okay, but even though serenity-js provides you with plenty of interactions and questions out of the box, writing your tests at this level might lead to rather long test scenarios that are perhaps not the most exciting thing to read. So let's talk about the fifth and the last element of the Screenplay pattern, the tasks. Tasks are the basic unit of composition that enables you to represent series of logically related activities using a language specific to your domain and your business. For example, we could model the interactions to navigate to the app and make sure that we're in the right place as a task to open the app. Serenity.js reports both the high-level tasks and the low-level interactions, so that you can see exactly what the actors are doing. And of course, you can compose higher-level tasks from lower-level ones too. This mechanism helps you model the business process, instead of mirroring the implementation of your system. It helps you focus on the actors using your system and the tasks they need to perform in order to achieve their goals. This change of perspective makes your tests not only easier to understand and maintain, but also your test code much easier to reuse and share. So let's create another task to implement the test scenario we talked about in the beginning. Since this time we'd like to add an item to the list and make sure that it's added correctly, I create a task that models this process. As we need our actor to interact with the website, let's define a lean page object that represents the web elements the actor should target in their interactions. Just like the Screenplay pattern, what I call lean page objects is another core pattern behind serenity-js. Lean page objects are similar to the original page objects, but instead of handling the responsibilities of describing the page structure, retrieving the data from the system, as well as modeling the interactions a user can perform on a given page, lean page objects have a single responsibility of modeling the page structure only. Now, since targets are questions, you can pass them to interactions. For example, an interaction to enter a value into a form field, or the one to press the Enter key. Those two interactions together is what constitutes a task to add an item to the list. Serenity.js makes modeling tasks take seconds, and gives you a natural way to capture the domain vocabulary in your tests, which is particularly useful on projects using domain-driven design or behavior-driven development. That's because while writing your acceptance tests, you create a domain-specific language describing your domain, which can help you reflect this business language not only in your tests, but influence the production code as well. So for example, in the domain of to-do lists, we'd have tasks to add an item, mark it as complete, filter the list, and so on. But in more complex domains, you could have tasks to create a customer record in a CRM system, pay with a default credit card on an e-commerce platform, or provide a delivery address in the logistics domain. Okay, so let's tell our actor to perform the new task. We'd also like our actor to ensure that their operation has succeeded. To do that, we use another question that ships with the serenity.js Protractor module, the one that retrieves the text of web elements. So I create a convenient alias for it to enrich it with domain-specific meaning. I quickly add an assertion to verify if the item was added to the list, and run the test again. Serenity.js reports all the activities performed by the actor, the questions they asked, and how long they took. And, because I gave my tasks meaningful descriptions, high-quality reporting comes pretty much for free. But speaking of reporting, Serenity.js provides great error reporting capabilities should the scenario fail. So let's break it real quick, shall we? Instead of asking the actor to ensure that the list contains one item, let's make sure that the list contains exactly two items, which obviously will fail. So I run the test again to see it fail and tell me what went wrong. Now, as expected, Serenity tells me that instead of two items, the actor encountered one. But the console log is not the only report I have available to help me diagnose the issue. In my Protractor configuration file, the protractor.conf.js, I've also configured the test runner to use the Serenity BDD reporter, as well as a photographer services. Which means that every test run produces JSON reports, as well as screenshots that Serenity BDD, a popular acceptance testing and reporting library written in Java, and the big sister of Serenity.js, can use to produce HTML reports and living documentation of our project. So let's generate a HTML report and see what it tells us. The report tells us that we've executed one scenario and that it's currently failing. We can drill down further to see the exact interaction that has failed, the assertion report, as well as a screenshot showing the state of the UI when the failure happened. Of course, Serenity reports all the interactions that preceded the failure, so that it's easier for you to understand what might have caused it. We won't cover Serenity BDD reporting in detail today, so if you'd like to learn more about it, please visit the serenity-js.org website. In our case, the issue is simple to resolve. So I go back to the test, reuse the task to add an item called love testing to our to-do list, and run the test again. As we expected, the test now passes. Okay, so now that you understand the Screenplay pattern and what serenity-js has to offer, let's look at full-stack acceptance testing. A basic requirement for full-stack testing is for the actors to be able to interact with more than one type of your system's external interfaces. Thankfully, our little demo app provides a rudimentary health check endpoint that tells us how long the server has been running for, and that I can use to show you how a UI test could interact with other interfaces. So, just like with the UI test, I start with actors and their abilities. In this case, I want my actor to be able to call an API. Call an API, just like the other API-specific tasks and questions, comes from the serenity-js REST module. I also want the actor to perform a new task to ensure the server is up. This task requires the actor to send a GET request to the health check endpoint and ensure that the last response status equals 200. Now, for extra brownie points, we could also make sure that the reported uptime is greater than 0. Serenity.js assertion methods can be composed together to perform this verification. I tell the actor to perform this API-specific task before the UI-specific part of the scenario starts, and run the test again. The great thing about hybrid tests like this one is that you can use those REST interactions to manage your test data via REST APIs, or check if the system is ready for a higher level test. Speaking of which, would you like me to show you what happens if I now shut down the server and run the test again? When a REST interaction can't establish a connection with the target server, it marks the test as compromised. A compromised test is one that couldn't be performed because of an infrastructure failure, outside of the test's control. Serenity.js also has a feature that lets you mark certain assertions as compromising the test. I'm sure you know how important it is to be able to distinguish infrastructure failures from test failures and assertion failures, as they can help you get to the bottom of the issue much quicker. Imagine if your test framework told you that all the UI tests have failed because someone shut down the server. You wouldn't have to spend time trying to figure out why WebDriver couldn't find an element on a page. Okay, so I'll put the server back on. There's one more thing I wanted to show you. Remember when I told you that Serenity.js not only helps you quickly write high-quality tests, but also reuse your test code across layers and avoid duplication? You might have noticed that there's an API test suite located under the spec folder in our project. This test suite is executed directly by Jasmine, so doesn't have access to Protractor or the web browser. The focus of this layer of my test suite would be on running the API tests. I've already created a test here to demonstrate that our API allows to determine if the server is up. Since we already have an actor capable of calling an API, let's give him something to do. But didn't we already have a task to ensure if the server is up? Well, yes, we did. So let's extract it from the UI test suite and move it down a layer to the API suite. Now, with this out of the way, let's reuse the same task in both test suites to avoid duplication. A good principle to remember here is that a higher level test suite can use the tasks from the layer directly below it, but never the other way around. Now, I can use another npm script I have defined earlier to run both my test suites. So the test API suite running the API tests and the test UI suite running the web-based tests. As you can see, both test suites have been executed successfully. Better yet, Serenity has produced a HTML report that documents the execution of both test suites in one place. So when you open the report, you see both the API and UI scenarios report together in a consistent manner. This type of reporting is particularly useful when you want to share the reports with people with no access to your codebase, like the business people or user experience designers, for example. It's also great in regulated environments, where the acceptance test reports and living documentation are used for audit purposes and to document business processes. Not to mention that even though I use Jasmine to keep this demonstration simple, serenity-js can be used with other test runners. In particular, it works with any version of Cucumber.js. Now, since serenity-js understands Cucumber Gherkin syntax, it can augment the HTML reports it produces with information from your feature files, to give even more comprehensive documentation of the test run. I hope that this demonstration made you more familiar with serenity-js and the design patterns behind it. I also hope that seeing both the framework and the Screenplay Pattern in action made you realize that writing high-quality, user-focused, full-stack acceptance tests is much more achievable than perhaps you would have thought. And since the building blocks you use to design your tests are just simple, high-quality code that follows solid design principles, your test code becomes easy to reuse not only across test suites, but also projects and teams, as you can package it up and distribute just as you would any other Node module. So, if you like what you saw and would like to try it yourself, read the docs at serenity-js.org, check out the sample projects on GitHub, including the one I just showed you, and let me know what you think. Thank you for your time. My name is Jan Molak, and it's been my pleasure to introduce you to version 2.0 of serenity.js, the next generation full-stack acceptance testing framework.